Hello, good morning to everyone. Myself, Dr. Sunny Kumar. This lecture is lecture number 2. It is a unit process subject. In the previous lecture, in the lecture 1, we have discussed about the products derived from the alkylation. So, generally, in the different drugs synthesized, we use these alkylation reactions such as anesthetics, antipyretics, alkaloids, antiseptics, and detergents and dyes, explosives, flavors, drugs, and lubricants and perfumes. So these are some examples where this alkylation reaction is generally we used to produce these type of products. So today we will discuss about the types of alkylations. So we will first we will talk about there are 6 type of alkylation reaction generally happening. So the first one will be this alkyl bound to carbon, and the second one is alkyl bound to oxygen, and third one is alkyl bound to trivalent nitrogen, and fifth one is alkyl bound to pentavalent nitrogen, and the sixth one is alkyl bound to metal. So these and the last one is alkyl bound to miscellaneous elements. So this is the outline, the different 6 type of alkylation process generally bounds we used. So now we will discuss about alkyl bound to carbon. So we have already discussed there is alkylation related to the 6 types. The linkage of alkylanes to carbon, oxygen, nitrogen or metal which affected by the alkylating agent. Example, ethyl chloride. So this is the example which is a now alkyl bound to carbon. These compounds may be considered as being derived by the substitution of an alkyl group for hydrogen in carbon compound. For example, alkylates for synthetic gasoline, ethylene benzene for styrene entering into the manufacture of plastic and rubber, and hexyl sorichinol, thymol and barbital and other barbituric acid alkyl derivatives are the examples of this alkyl bound to carbon. This type of alkylation is frequently refers to as alkylation of hydrocarbons, and many of the instances are nuclear alkylation. An alkyl bonds to nitrogen or to oxygen may wander to the nucleus. Example, aniline is converted to dimethyl by heating to about 205 degrees centigrade with methanol and a small amount of sulfuric acid. If the temperature is raised to 250 to 300 degrees centigrade, considerable nuclear alkylation take place. So as shown in this reaction, so where this is a benzene group and this is the amine group is attached, and sulfonated. So when it is treated with a small amount of methanol and sulfuric acid at this temperature, so the changes is coming here. The methyl group is attached here, CH3, it is attached in this alkylation is happening. In the presence of excess methanol and at high temperature, instead of 250, we will raise the temperature up to the 300 to 350 degrees centigrade. So the macedin as well as mono and dimethyl derivatives are formed. So you are seeing this in the benzene group. So these are the 3 methyl groups are attached on this. So the mono and dimethyl derivatives are formed as shown in this example. A similar rendering of the ethyl group in the case of diethyl aniline has been studied by the Johnson et al. When aniline is alkylated, the alkyl group can react in many cases either nuclearly or at the nitrogen atom, depending mainly on operating conditions. The operating conditions are temperature, pressure, flow rates, these are the things. When the reaction is predominantly nuclear, the alkyl group is attached to the nitrogen and wanders to the ring. So the hat and eleuterio alkylated phenols and cresols, which methyl phenyl chloromethane, both carbon and oxygen alkylation occurs. In the case of carbon alkylation, the reaction proceeded directly to the final product rather than an intermediate ether. It is a very important point. So in other alkylation like oxygen or nitrogen, they have some intermediate, but in the case of carbon there is no chance for the intermediate, which is generally ether. These authors found that alkyl aryl ethers did rearrange under the influence of fairly high temperature, so that the alkyl group wandered to the nucleus. Parabens and aromatics can be alkylated with alkyl halides in the presence of catalyst, which generally are Friedel-Crafts types. So you in 10-12 you have already read about this Friedel-Crafts reaction. The alkyl group replaces hydrogen on a carbon atom and hydrogen halides is released. Carbon linkage alkylation includes the Wurtz reaction for the preparation of aliphatic compounds. So this is this reaction, which is CH3Br plus 2Na plus Br C2H5 is C3 and dash C2H5 plus 2NaBr. So this is salt is forming, and this is the alkylation linkage is happening, carbon linkage alkylation. And alcohols and ether will often react with aromatics hydrocarbons to produce alkylating aromatic plus water. Both methanol and dimethyl ether are used to alkylated various aromatic at temperature from 250 to 600 degrees centigrade and at elevated pressure. Aluminosilicate is often employed as a catalyst for these reactions. For liquid phase reaction at lower temperature and pressure, boron trifluoride and hydrofluoric acid has been found to be effective catalyst for condensing alcohol and aromatics. So these compounds which decompose readily into free alkyl radical such as peroxides, mercaptans, will alkylates, hydrocarbons. Competitive reactions occur as follows. So this is free radical reaction, R dot plus R dash H, which produce RH plus R dash, R dot plus R dash H, which produce R dash plus H. These radical compounds. So the first reaction was found by Lévy-Szwarc to be predominant when methyl radicals attacks isooctanes. The second reaction is predominant. This second reaction is predominant. However, for aromatic hydrocarbons, the free radicals forms in above two reaction will react with each other, with other free radicals or with impurities. The affinity of the methyl radicals to attacks and aromatics increase in the following orders, like benzene, diphenyl ether, pyridine, diphenyl benzophenone, naphthalene, quinolone, phenolphthalein, pyrene, and anthracene. The ability of the free alkyl radicals to interact with isopropyl benzene and cyclohexene decrease in the following order, like methyl ethyl, and this propyl and butyl, and isopropyl, secondary butyl and tertiary butyl. So this is the order of free radicals interact when with isopropyl benzene and cyclohexane. So the olefin alkylation of paraffins, here the reaction involving paraffins and olefins may be represented as follow: RH plus RCH, and this CHR double dash, that will create R dash RCH CH2 R dash. So this is a paraffin. Generally we generate alkylation of olefin alkylation of paraffins, where RH is normal paraffin or isoparaffin, and R dash and R double dash are either hydrogen atoms or monovalent radicals, ethyl or ethyl, methyl or ethyl. Alkylation of this normal paraffin involves addition of R at one of the doubly bound carbon atoms and hydrogen at the others. The R group sometimes wander on the chain. Alkylations of this type forms longer chain compounds of the paraffins and isoparaffin series. So this olefin alkylation of aromatics, the benzene, toluene, xylene, naphthalene and phenols are aromatics which are commonly alkylated either Friedel-Crafts type or protonic acid. Catalysts are normally used. Olefin frequently employed are ethylene, propylene, butene or isobutene and butene 1, pentene and octane, nonene and dodecene. So these are some olefins are. The nature of alkylation action of normal butylene upon benzene in the presence of sulfuric acid at 5 to 60 degrees centigrade, as shown this. if you will increasing the percentage of H2SO4, so the dissolution in the sulfuric acid at 5 degrees C, and this at 60 degrees C. The 60 degrees C, it is a maximum dissolve you will get. This is an butyl dissolved in sulfuric acid. This is a solubility chart. The stronger sulfuric acid, the further the alkylation proceed with the higher boiling point of the products. The primary reaction may be represent like this. So this is the reaction, and this alkylation, olefin alkylation of aromatics happening. So the aluminum chlorides catalyze many alkylation. Paraffins, benzene, toluene and xylene are alkylated by olefins and cyclopropane in the presence of aluminum chloride. Usually hydrogen chloride is needed as promoter, like alkylates for the petroleum industry. So the condensation of the alkyl or aryl halides according to the Friedel-Crafts catalyst is a form of nuclear alkylation for preparation of aromatics derivatives. The relative rates of alkylation for several aromatics, like this is a reaction in the presence of aluminum chloride catalyst. So this aromatic compound is now attached, this alkyl halides group is attaching. So using the Friedel-Crafts type catalyst have been reported by Scandon. The toluene, ethyl benzene, cumene and tert-butyl benzene have relative rates 2.1, 1.8, 1.7 and 1.4 respectively compared to the benzene. So relative rates of reaction for the meta and para position were found to be approximately equal. So the steric hindrance, however, cause the rates of decrease at the ortho position as the size of the alkyl group increased. The phenol and cresols that have been alkylated with tertiary olefins find uses as fuel additives that act as antioxidant and inhibitors. The preparation of 2,6-ditributyl 4-methylphenol is as, so this is the reaction. This benzene group OH attached and CH3 plus 2 CH2 CH2C, and if they are, so this group is attaching in this in both sides. The sulfuric acid is usually used as a catalyst, but Friedel-Crafts type catalysts are also effective for alkylation of this type. Relatively long olefins are employed to alkylate phenols using sulfuric acid as catalyst. Such alkylate phenols find uses in producing oil additives. When formulated is added to the alkylate phenols mixtures, a condensation reaction occurs and aromatic rings are linked together by methylene group, as you are seeing here. Calcium hydroxide is employed to neutralize the mixture and to obtain the following oil additives. So now this is the reaction, this is the compound you will get. This is a long chain compound you will get after the condensation reaction occurs. They are linked together by the methylene group. So this calcium hydroxide is employed to neutralize the mixture. So next one is the aromatic fraction can be alkylated with olefins to produce products which are used as synthetic lubricants. An aromatic reaction boiling between 160 and 210 degrees centigrade is generally alkylated with C14 to C18 olefins in the ratio of 2:1. A higher boiling aromatics fraction is 2102 to 260 degrees is reached within C8 to C13 olefins in the ratio of 1:3. Aluminium chloride promoted with the hydrogen chloride is the catalyst normally used. So previously we have also used this aluminium chloride catalyst. When the alkylated aromatics are blended with thickeners such as polyisobutylene, the mixture obtained is an excellent lubricant with good viscosity index, stability and pour point. So now we will discuss about alkyl bound to the oxygen. How this alkyl group bound to the oxygen. The previous one is alkyl bound to the carbon. Now we will discuss alkyl bound to the oxygen. The alkyl bound to the oxygen, the compound of this class are generally prepared by substituting an alkyl group for hydrogen in the hydroxyl group of an alcohol or phenol. Typically, compounds containing this alkylations linkage are the following. So these are the some alkyl linkage. The aliphatic ethers, which are cellulose ether, benzyl cellulose, carboxyl methyl cellulose, ethyl cellulose, ethylene glycol ether, carbitols, cellulosol, ethyl ether, isopropyl ether, and the phenol ether and derivatives are acetophenatidine or anisidine, anisole, codeine, methyl ether of morphine or dianisidine, guaiacol, beta naphthyl methyl ether or nitroanisols, vanillin. So these are some alkylation which are ethers and phenols derivatives, phenols ether derivatives. So these aliphatic ethers, the aliphatic ethers used in the industry are made usually by the action of sulfuric acid on the alcohols. Ethyl ether and isopropyl ether are thus prepared. However, more ethyl ether than the market usually absorb is obtained as by product of the hydration of ethylene to alcohol. Alkyl halides reacts on hydroxyl group either directly or in the presence of alkyl or after the hydrogen of a hydroxyl group has been replaced by sodium. This is a Williamson synthesis which is particularly applicable to the making mixture ethers. So this is a reaction. This C2H5O Na plus C2I, which is a halide group, and so this is a replacing, this group is replacing here, and this salt is forming sodium iodide you are getting. So C2H5OH plus CH3Cl NaOH, so you will get replacement alkyl group is attached here, replacing this oxide group, alcohol group, and they are getting here, and salt and water is formed. Often the cheaper and the sufficient satisfactory procedure is to react an alcohol and alkyl halides in the presence of alkali. The cellulose ether are generally made by the action of alkyl or alkyl halides on alkyl cellulose. The reactions are carried out under the pressure at about 100 degrees centigrade. The alkyl derivatives benzocellulose, which is employed in plastic industry, is made similarly. So this is a reaction which is happening. So here is also salt forms when the halide groups is reacting this ether, cellulose ether. Now the phenol ether are prepared similarly to the aliphatic ether. An alkyl halide is sodium alkyl sulfate, dialkyl sulfate, or alkyl toluene sulfonate is treated with the phenols in an alkyl medium or in the presence of metal halides. The naphthalones are alkylated more easily than phenols. Heating of naphthols with methanols in the presence of sulfuric acid or alumina being sufficient to give satisfactory yield. So the another component by this bond with oxygen is alkaloids. Some of the most difficult oxygen alkylations are those involving the alkaloids, where the alkylation is often carried out to replace the hydrogen of hydroxyl group in the presence of tertiary nitrogen of the alkaloids. The best commercial example of the work that has been with a particular group of compound is the formation of codeine by the alkylation of the phenolic hydroxyl in the morphines. Outline of this alkylation with quaternary or amino compounds are given under codeines. Such as procedure is also used for thiobromine, antipyrine, etc. So we have discussed about today in presentation the types of alkylations. We have discussed that there is a 6 type of alkylations, in which we have only the 2 type of alkylation is discussed, that alkyl bound to carbon and alkyl bonds to the oxygens, and what are the catalysts we are using, and what are the sulfuric acid and this catalyst we are using. And in the bonding with the carbons, there is a no intermediate step, we are directly getting the products, but in the case of oxygens we are generally get the intermediate steps also. So in the next lecture we will discuss about alkyl bonds to the trivalent nitrogen, alkyl bound to the pentavalent nitrogen, alkyl bound to the metals, and alkyl bonds to the miscellaneous elements. So these topics we will read in the next lecture. So thank you very much. If you have any query related to this topic, so you can email me on this. This is the email ID is given here. This is chemicalsanira@gmail.com, and this is the website. So thank you.